You spend countless hours building your application and it works like a charm in your machine. But the moment you want to show it to your friends, it doesn't run. Why? Because it only runs on your machine. And that's how to solve this problem Docker was born in 2011 by Solomon Hykes. So in this video I'm going to explain what is Docker and how you can use Docker in your development. Docker helps you build, test and deploy your application in an isolated environment and breaks the barrier of your system dependencies. Initially, Docker can be divided into two parts, Docker container and Docker networking. These topics can be covered in a different video of itself, but we're going to see an overview of the followings and focus on how you can practically use Docker itself. Before we go deep, we need to know about Docker daemon. The Docker daemon, also known as Dockerd, is a process which listens for Docker API requests and manages Docker objects such as images, containers, networks, and volumes. A Docker container is a sandbox process on your machine that is isolated from all other processes that are running on your machine. A container is a runnable instance of an image. You can create, start, stop, move, or delete a container using the Docker API or CLI. A container can be run on local machines, virtual machines, or deployed to the cloud. A container is portable and can be run on any operating system. A container is also isolated from other containers and runs its own software, binaries, and configurations. One of the reasons Docker container and services are so powerful is that you can connect them together or connect them to non-Docker workloads such as your host machine's workloads. Docker containers and services do not even need to be aware that they are deployed on Docker or whether their peers are also Docker workloads or not. Whether your Docker hosts run Linux, Windows, or a mix of the two, you can use Docker image to manage them in a platform agnostic way. Docker networking can be divided into 5 parts. These are called network drivers such as bridge, host, overlay, IP VLAN, and MAC VLAN. Bridge is the default network driver in Docker networking. Even if you don't mention any network driver while creating Docker container, Bridge network gets created automatically. Bridge networks are usually used when your application run in an standalone containers that need to communicate between containers running on different Docker daemon hosts. Bridge networks are best when you need multiple containers to communicate on the same Docker host. For standalone containers, host network drivers removes network isolation between the container and the Docker host and use the host's networking directly. In this case, the Docker container does not get its own IP address allocated. For example, if you run a container which binds to port 80 and you use host networking, the container application is available on port 80 on the host's IP address. Host networks are best when the network stack should not be isolated from the Docker host, but you want other aspects of the container to be isolated. Overlay networks connect multiple Docker daemons together and enable a service called swarm service to communicate with each other. This type of network can also communicate between a swarm service and a standalone container, or even between two standalone containers on different Docker daemons. Overlay networks are best when you need containers running on different Docker hosts to communicate or when multiple applications work together using swarm services. IP VLAN network driver is like a virtual network device that can be used in a container environment to access the host network. This IPv4 driver gives user total control over both IPv4 and IPv6 addressing in their Docker networks. MAC VLAN networks allow you to assign a MAC address to a container, making it appear as a physical device on your network. The Docker daemon routes all the network traffic to containers by their MAC addresses. Using the MAC VLAN driver is sometimes the best choice when dealing with legacy applications that expects to be directly connected to the physical network rather than routed through the Docker host network stack. Macfiller networks are best when you are migrating from a virtual machine setup or need your containers to look physical hosts on your network, each with a unique MAC addresses. Now that we have covered Docker container and Docker networking, it's time to learn about Docker commands. Majority of the time in a typical development flow, some of the basic commands are used repetitively. Let's go through them one by one. Docker pull command is used to pull a Docker image or a repository from the Docker hub or registry. An image is a set of instructions to build a Docker container. When you run Docker pull command, it expects the name of the application and optionally a version tag of that application. As an example, I want to pull this Nginx image from the Docker hub. To pull this image, I need to run this docker pull nginx command. Notice that it is pulling the latest version of Nginx Docker image. To pull a different version, you need to provide the version tag followed by a colon symbol. To manage Docker images in your machine, you need to use docker image command. To see existing images, you can run docker image ls or docker images. Both will print all the existing Docker images present in your machine. You can see I have the Nginx image that I just downloaded. It has a tag, an image ID, when it was created, and the size of the image. Docker build command is used to build an image from a Docker file. A Docker file is a file that contains some set of instructions that are required to build an image and contains all the information an application would have. To show you, I have created a demo to-do list project. In the root directory of the project, I am creating a Docker file. In this Docker file script, I am defining instructions such as the base image to use, in this case Node 18 Alpine, which is a lightweight version of Node.js running on the Alpine Linux distribution. The working directory for the commands that to follow the Docker demo project path. The copy command copies all the files from the host machine to the container's work directory. Then runs the command yarn install -- production, which installs the dependencies defined in the package.json file only in production mode. To build an image from the newly created Docker file, we need to run the docker build command. The T flag tags a name of your choice to your image. Finally, the dot at the end of the docker build command tells Docker that it should look for the Docker file in the current directory. To check newly created image, you can run docker images. And yes, we have our tagged images, and the base image is Node 18 Alpine, which we have defined previously. To run an application in a container from an image, we use docker run command. To run the image that we just created, we can give the command as docker run -d -p 3000:3000 demo docker app. The D flag is to run the new container in detached mode, which means in the background it will run. The P flag is to create a mapping between the host port, which is 3000, to the container's port, which is 3000. Without the port mapping, you won't be able to access the application. And at the end, the image name that we are going to use, which in this case is demo docker app. Once the command is successful, it gives back an ID. Because we have mapped our host port 3000 to the container port 3000, we can now see and access the app that we just ran inside a Docker container. When I visit localhost:3000, you can see the application is running and all the functionalities are working as expected. We use docker container command to manage all the containers that are available in our systems. To see our running container, we can run either docker ps or docker container ls. This will show us all the running Docker containers that are available. To enter into a Docker container or run a command in a running container, we use docker exec command. For instance, if I want to enter into our newly created container, I can run docker exec -it followed by either container ID or container name, and then specifying the environment, which in this case is shell. Now we are inside the container and the host name of the container matches with the container ID. To stop the running container, we can use Docker stop followed by the container ID or the container name. Same goes for when you want to start a container.